today we'll talk about the design and the whole process behind making engine mounts that we use here. This mount here is 7075 aluminum, CNC machined out of a single piece. We use Xometry, and we used their overseas service for this, so I imagine it was probably made in China. But really the results of this are quite good. The machining finish is good, the fit compared to design is great. And so far, everything we've got from them has been good. So the way we start designing these is we use, it's right here. We use the 3D printer. So step one is to find out what this bolt pattern is here. So we've got the bolts on the transmission. We put some bolts into each of the holes, measure outside of them with the caliper. 1, 2, 3, 4, 5 or so measurements. Once you have all those measurements, you can just draw 4 holes wherever in SolidWorks and then put the constraints on the holes. So these two are 53 millimeters apart. These ones are 80, whatever. And once you add enough dimensions in, it automatically puts them where they need to be in on the 2-dimensional plane. Then from there, we need to go to where the engine mount's going to be. And for this car, the engine only exactly fits in the car by a couple of millimeters. So the engine mount could only be basically exactly right here. And if you want to come around to this side, Brian, real quick, you can see our clearance to some of the bolts in the transmission is very, very small. The mount gets held just slightly on an outward angle when it's in the car. I'm not strong enough to bend it here, but that clearance is a little bit more. But it gives an idea of how much we were working with on this one. So once we knew where the mount had to be, we knew where the plate had to be, we started making iterations of this that just had a little bar to come up and hold the mount. And we'd print one and put it on and be like, oh, that was too close. Okay, a couple of millimeters out. All right, perfect. Then we use this, put the engine and the mount and everything in the car. And we checked what angle we needed to have between this surface and this surface. And we just used jacks and moved the engine around until it was in the best spot. Found that it needed to be, I don't know what that is, 20-ish degrees of angle between the two planes. So now you've got all of the information you need to make the mount. You've got the bolt pattern, you've got where the mount needs to go to, and you've got information about what is going to be in your way between those two. So you can see on this one, the shape of it's a little bit weird. It's because the turbo sits right here. So when everything's together, the turbo is maybe 5 millimeters from the bottom and 3 millimeters from the side of the mount right there. And that's why the weird shape connecting the two different parts of it together. And in terms of how we design for strength, I'm going to steal this from another YouTuber who said, just look at it. There's quite a bit of material there. It probably could have been a little bit thinner, which would have resulted in being lighter, but given how much power this car is going to have and the consequences of this mount failing, it didn't seem like it was really important to shave a couple of ounces here when we don't have SolidWorks simulation. Now, if we did have simulation, we would have just given it these 2 points and let it fill in the design between the two, and it would have looked like an alien made it, which would have been cool, but that's a project for another year, I think. So once we have that design, we do the final 3D print, which you can see here. We fully mocked this up in the car, installed the engine mount onto here, bolted this down, made sure it cleared the turbos, and then sent this off to have it made. It was about $500 per side to have these engine mounts made, which is interesting because this one's quite a bit bigger than the other one, but they ended up being the same price to machine. So there must be something about the other one that was kind of machiningly complex. That's kind of the whole summary of these. So when we go to bolt this down, we'll make sure we use grade 12 bolts. We'll make sure we Loctite them, torque mark them. And then, every 10 minutes, then every hour, and then every 5 hours, we're going to come back and check these again, because these will be one of the main potential failure points of the car is the bolts coming loose on the engine mounts, given that we expect this to vibrate a little bit. Yeah, the last thing to do is now to mount the chassis side mount. It's I don't have it over here. It's really a fairly simple thing. It's just 2 plates like this, and then a bar in between them that this sits on. I just cut that and weld that in-house here. I have some of the parts of it laser cut by Send Cut Send. We'll take those and just add a couple little brackets to stiffen them up for this particular application. That's how we make custom engine mounts for engine and transmission pairs that have never been done before.